Hello and welcome to Alt+Prog. My name's Mark and I like talking about computers. And in this video, we're going to look at something that's kind of fallen out of favour in the past 40 years and find out why. I'm talking about flowcharts and pseudocode. What's happened to them? Where did they go? Let's find out.
Let's look at a simple computing problem that we might want to design a solution for using a flowchart. Here's one. We want to list all the numbers from 1 to 10 along with their squares and cubes. How would you solve that? Well, one way would be to design the solution using a flowchart, and here's one. So what we do here is we've got a flowchart. Each of these boxes represents a thing that you have to do to solve the problem, right? So we probably start off by setting some kind of count to 0 and then go around in what's called a loop where we do things over and over again until the count is at least 10 and then drop out. And then inside the loop we'll add 1 to the count, work out the square and the cube and then display the results. And then go back round and do it again and keep doing it until we get to 10. Or we could, rather than use a flowchart, just write out the code first as a set of sentences. So we'd say here we're going to set the count to 0, we're going to go round in this loop until the count is at least 10, add 1, set the square, set the cube and display the results. And this is called pseudocode. It's not actual code that will run on a computer, but it's code that's laid out in English for people to read. And this is what the code might look like. And in this case, we're looking at the code written in Python. So in Python, we've got a variable called count that we set to 0 initially. Then we use this while statement to test whether count is less than 10. And if it is, we go into this while loop where we add 1 to the count, work out the square and the cube, and then print the results. Now, I know what you're going to say. It's obvious. Yeah, it is. If you were writing the solution to this problem in Python, you probably wouldn't bother with a flowchart or pseudocode. But here's something to keep in mind. Python didn't exist 40 years ago. Very likely you would have had to write code like this. And then you might want to think twice about not using flowcharts. Or maybe not. Kind of up to you, really. So flowcharts have fallen out of favour. Well, there are lots of reasons. For one, they take a long time to create or change. That flowchart, as I showed you, probably took half an hour to create on a computer. But the Python code, easily knocked out in 5 minutes. Why would you bother? For modern software design, which is much more complicated than you can represent on a single sheet of paper or a single computer screen, there are better ways of designing the software. A lot of modern software is designed using something called object orientation. And flowcharts are not really great for that. You'd need hundreds or thousands of them. And in the modern IT shop, most of them now use something called agile management. That means they get their staff to do small, simple changes that can be turned around in a couple of days, maybe a week. And there's no time to do flowcharts or pseudocode. They need to just get that change done, get it done now, get it in the live system. And then finally, let's not forget that AI can do a lot of the boring stuff for you.
So that's why we don't see flowcharts much anymore. What about pseudocode? Are there any other reasons we don't see that?
Pseudocode has also fallen out of favour because it's unlikely to stay in step with the actual code. Once you write the code, you start testing it, you change it. Are you going to go back and change the pseudocode too? I think not. And with a lot of modern programming languages, it's very easy to put comments in the code. And so you can write code with comments where you've got a description of what's going on. And a lot of programmers will actually start out by writing the comments for the code before they write the code itself, so that they have clear in their mind while they're writing the code what they need to do.
So that's why we don't see much of flowcharts anymore for designing programs, although they're still used a lot for high-level process documentation. For modern software, we have better methods of planning out the design of the program, such as the Unified Modeling Language, UML, or Entity Relationship Diagrams, ERD.
But flowcharts are still good for a few things. For example, teaching the basics of programming to new students who may not know quite how to break down problems into small, simple steps. And for high-level process flow design, where the concepts are unlikely to change at that very high level, even if the details do. And then also for describing code in textbooks, technical documentation or meetings, once the code has been written and tested and is working.
So back in the day, we'd draw our flowcharts by hand, we'd write our pseudocode by hand, or maybe type it into a text editor. But do we still need to do that today? Nope.
Welcome to Flowgorithm. Flowgorithm is more than just a flowchart drawing system. It's a programming environment in its own right, with its own language that you draw out using flowchart symbols. You can test and you can run Flowgorithm programs. Flowgorithm is free to download, but there's one snag. You guessed it, it's Windows only. So for you Linux and Mac users, suck it up. No, I didn't mean that. I mean, sorry. Anyway, let's go ahead and install Flowgorithm. You know what that means. It's demo time. Okay, so let's get Flowgorithm installed. Now, we need to install this on Windows, and this is obviously not a Windows computer, but I have a little dirty trick which I'll tell you about some other time. So here's a Windows computer I prepared earlier. And let's go and install Flowgorithm. So I just need a web browser. And then I will go to flowgorithm.org. And there's the home page for the Flowgorithm project. Now all I have to do is click download. It's a free download, and click on the install link, and there we are. I can just open up that file I've just downloaded, and we'll click setup, and then just watch it happen, right? So next, through the installation prompts, do I agree to the license? Yeah, I think I will. Yes, I do want to install it. And we're done. It's installed. And there it is. Flowgorithm, he says. There it is. Right, so now we've installed Flowgorithm. Let's use it to design the solution to our listing of numbers from 1 to 10. And you know what that means? Yes, it's demo time again. Right, so let's have a go at solving this problem of printing the first 10 numbers along with their squares and cubes. So here we are in Flowgorithm. I'm going to make this window as big as I can. And we're going to start coding. So if you remember from the flowchart, we basically need to set a count to 0 and then go around in a loop until the count reaches 10. So let's start with the count. We'll set that to 0, and we assign the variable count the value of 0. Simple as that. And then we need to go around in a loop. Now here's the thing. In the flowchart, we did a check at the top of the loop to see if the count was at least 10, and if it was, drop out. If not, we just went back into the loop. When you do that kind of check repeatedly, that's what's called a while loop. So that's what we're going to use. A while loop, and inside the while loop, we're going to make sure that count is less than 10. And what happens now is if the count is less than 10, we go round the loop, and if it's 10 or more, we'll drop out here. So now we need to add 1 to the count and then display the, just for simplicity, we'll stop there for now. So we need to assign again, and this time we're going to say that count is equal to count plus 1. And that will have the effect of adding 1 to the count every time you go round in the loop. And then we'll just output what count is. There we go. And that's it for now. We'll add in the rest of the bits in a moment. So let's just test this program and see if it works. And you can do that by using these green buttons here. This green button just runs the whole program, and this lets you run the program one statement at a time, or one box at a time here. So we'll try stepping through first, and let's go. And oh, we hit an error straight away. And what does it say? Before you can store or read data from a variable, it must first be declared. Now this is a common thing that you have to do in many computer programming languages. You can't just simply use a variable without first telling the program what kind of variable it is. So we can fix that by adding in a step here to declare the variable. So we're going to declare the variable count, and we're going to declare it to be a type integer, which it is already. That means whole number. And we don't need to check this box because it's just one integer on its own. And now, if we try stepping through the program again, we'll see that we don't get the error. We go into the loop, we add one to the count, and we've got a console now. So if we step through there, we get the number 1. Okay, now that's what we'd expect. Now we've gone back to the top of the while loop, and we're going to go around again, I think. Yes, we are, because count isn't up to 10 yet. And there we go. And we'll keep going on like this, just like this, until we get to nearly there. This should be the last time through the loop. Let's just see. There's the 10, and the value of count now, well, it's now 10, so we're going to drop out to the end. That's our program running and working correctly. Now we need to add in the squares and the cubes. So this is one simple way we can do it, right? We'll just say, right, we've got the count. So what we'll do is we'll assign another variable called square, and we'll make that equal to count times count, just like that. And click OK, and then we'll do another variable called cube, which is equal to count times count times count. Okay, that's good. But don't forget that if you assign a new variable, you need to tell the program what kind of variable it is. Now we can do that here, or we can do that up at the top over here. I'm going to do it here. It doesn't really make a lot of difference in a program like this because it's very simple. You can declare your variables right where you need to use them. That's the usual way we do declarations in modern programming languages, but with a lot of older ones you'd have to do the declaration at the top. Anyway, square, we're declaring, and that's another integer. And then we're going to declare cube like this, and that is also an integer. So that's all good, so that when we run this program now, well, we've not output the square or the cube yet, have we? So we need to output those. So let's just do that. Just like that. And now we're going to increment the count, calculate the square and the cube, and then output the count, the square, and the cube. Let's see that running. And then we'll see a slight snag with this program, because we're really not there yet. And here's the snag. You see what the output looks like? Yeah? It's outputting the count, then the square, then the cube, then it's going on to the next count, then its square, then its cube, and so on. Can you imagine if you're looking at the output of the program, how confusing that's got to be? We need to make this output a little bit neater, a little bit easier for a human being to read. So let's do something here which will put the count, the square, and the cube all on one line, separated out by spaces. So I'm going to do another output. Now with output, I could just output a single integer like I've done. So output the count, output the square, output the cube, that's fine. But if I'm going to combine these things together, and put spaces in between them, then I need to turn the whole thing into a string. So I need to turn the integers, count, square, and cube into a string, and then I need to put all these strings together. And there's a special function in Flowgorithm called toString. And that will turn an integer into a string, and then I can just do a concatenation. Then I can do another toString for the square. And then I can do another concatenation and a space. The ampersand sign here, this ampersand just means join these strings together. So that's the expression. We're going to take count, turn it into a string, add a space, then add square turned into a string, then add another space, and then add cube turned into a string. And that's what we're going to print out. So let's do that. And let's run this program again and see what it looks like. Well, yes, these lines look okay, don't they? These, and this one, and this one. But we've still got these numbers being spat out too. And that's because we may be spitting out the nice formatted line now, but we forgot to remove these boxes that print the count, the square, and the cube. So let's get rid of those. So they're gone now. So if we run this program again, we just get that. And that's the way to do it in Flowgorithm. Okay, we're not done yet though, because Flowgorithm has another trick up its sleeve. You can take this flowchart that you got now, and you can turn it straight into code. In this case, I'm turning it into Python. But I don't have to turn it into Python. I could turn it into some other language. For example, I could turn it into visualbasic.net if I wanted to. Or I could turn it into C++. What I would warn you about though is when you look at this code that Flowgorithm has spat out for you, yes, it'll work, but it's not the way an expert Python programmer would write it. And I just wanted to warn you about that. So it's great if you want to do a first cut of the code, but once you've produced your code, if you're an expert in the language, you'll probably want to tidy it up and make things a bit neater and a bit more efficient.
So that's Flowgorithm, and that's it for now. In a future video we'll do more with Flowgorithm. In the meantime, if you've enjoyed watching this video, please like, subscribe, tell your friends, and let's learn together and carry on coding. Thanks for watching. Take care everybody. Bye for now.